All right, thank you so much for joining us today. This is the last video towards the preparation of our final exams. And this is section B questions on vector algebra. Let's jump right in. So the first question is asking us to find the constant or the scalars A, B, C, given that R4 is equal to A R1 plus B R2 plus C R3, right? So R1, R2 up to R3 is provided, so we can, up to R4 is provided, so we can find for the constant A, B, C. So let's just do substitution here. So I have R4 here, so I'm just going to write it. 3i plus 2j plus 5k is equal to A times 2i plus minus j plus k plus b times R2 is I plus 3j minus 2k plus c, R3 is minus 2i plus j minus 3k. So this is what we have. So what we just need to do is we expand them and then we group like terms on the right and then we compare direction to direction. So I have 3i plus 2j plus 5k is equal to, this is the same as 2ai plus minus aj plus ak plus bi plus 3bj minus 2bk plus or minus 2ci plus cj minus 3ck. So let us group like terms and see what we are going to get from this. Let us group like terms and see what we are going to get from this. So group all I directions. So I have I here, I have I here, I have I here. So when I factor I out, I'm going to have 2a plus b minus 2c all I, right? Then I have j here, I have j here, I have j here. So when I do that, I'm going to have plus minus a plus 3b plus c j. Then the last one is the one with the k. So I'm going to have plus a minus 2b minus 3c k, right? So that's what I'm going to get. And then the left is this plus 5k. So now we are going to group like terms I. So I have the I here, I have I here. It implies that 2a plus b minus 2c is equal to 3. So this one is equal to what is here. And then coefficient of j is also equal to this. So I'm going to have minus a plus 3b plus c is equal to 2. And then the last one is going to be a minus 2b minus 3c is equal to 5. So this is what we are going to get at the end of the day when we expand the function. So now that we have three variables, so what we just need to do is now we solve them simultaneously to get the functions. So let's try and see something. Now let's come from B. So let me call this one equation 1, equation 2, equation 3. So from equation 1 we can make B the subject. We are going to have B to be equal to 3 minus 2a plus 2c. Right? So let me call this one equation 4. Right. Now what I'm going to do is now we've used equation 1. So let me put equation 4 into equation 2 and let's see what we are going to get. Equation 4 into equation 2. I'm going to have minus a plus 3 times 3 minus 2a plus 2c is equal to, plus c is equal to 2. So that's what we are going to get. Now let's try and simplify and see what we are going to get from here. Minus a plus 9 minus 6a plus 6c plus c is equal to 2, right? Now this is going to give us minus 7a plus 7c. Then I'm going to move the 9 to this side and I'm going to have 2 minus 9. So that's what I'm going to get from there. Now let's try and simplify here. We are going to have minus 7a plus 7c is equal to minus 7. Then I'm going to divide through by, let me say, minus 7. So when I do that, I'm going to have a minus c is equal to 1. So a will be equal to 1 plus c. Let me call this equation 5. Then what I'm going to do is I've used equation 2, so I'm going to plug equation 5 into equation 3, right? So let's do that. So put equation 5, or we can, for us to get the other variable, which is c, we can plug in equation 4 and equation 5 into equation 3. So a, this is equation 3 here. So a, equation 3 is a minus 2b minus 3c is equal to 5. That's equation 3. So let's just do the substitution. So a is equal to this. So I'm going to have 1 plus c minus 2. What is b? B is equal to this from equation 4. So b is equal to what is b? B is equal to 3 minus 2a plus 2c minus 3c is equal to 5. So what are we going to get from here? So let's try and simplify. C minus 2 minus 2. So this one is going to be minus minus 6 plus 4a minus 4c minus 3c is equal to 5. So you see that now this is in terms of only not only, let me see something here. Okay, we are doing it right. So now we are going to have 1 plus, now we have c here, we have c here, we have c here. When I combine them, I'm going to have minus 6c, then minus 6 plus 4. But we know that a is 1 plus c. So this is going to be equal to 5. And I'm going to have minus 6c minus 5 plus 4 plus 4c is equal to 5. So when I combine this and this, I'm going to have minus 2c. And then when I combined this and this, I'm going to have minus 1, which is equal to 5. So this is going to be minus 2c is equal to 5 plus 1. When I add 1, I'm going to have minus 2c is equal to 6. And c is going to give us minus 3. Yeah, so this is right. Now that you've gotten, c to be equal to minus 3 from equation 5, we have this one here. So now a is equal to 1 plus c. So this implies that a is equal to 1 minus 3, which is equal to minus 2. And then we had b to be equal to, b is equal to 3 minus 2a plus 2c. So let's plug them in. B will be 3 minus 2 plus 2 times minus 3. And this is going to be 3 plus 4 minus 6. And this is going to give us 1. Good. So now, indeed, our constant or our scalar a is equal to minus 2, b is equal to 1, and c is equal to minus 3. So that's what we are going to get for our functions. Right. So here, pay attention. When you are doing it, if you don't take care, you do some mistakes from there. Now let's look at question 2. Now question 2, we want to find the equation of the plane, right? We want to find the equation of the plane. But sorry, we want to find the equation of the line of intersection of the plane. So what we just need to do is the word intersection, right? So it means that we need to solve this one simultaneously. So let's see how we can solve this. Now this one, I'm going to write 2x minus 3y plus 3z minus 4z is equal to 0. Let me call this one equation 1 and pick x plus 2y minus z plus 3 is equal to 0. I'm going to make s the subject here. So I'm going to have z minus 2y minus 3. So I'm just moving this one to the right side. And let me call this one equation 2. So I'm going to put equation 2 into equation 1. And this is what I'm going to get. I'm going to have 2 times z minus 2y minus 3 plus minus 3y plus 3z minus 4 to be equal to 0. Right? So when I do that, then I'm going to have 2z minus 4y minus 6 minus 3y plus 3z minus 4 is equal to 0. Now let's try and group items. So I have z here, I have z here, I have y here, I have y here. So what am I going to get? Okay, let me deal with the z first. So I'm going to have 5z. Then the one with y is this and this. I'm going to have minus 7y. And then the one without anything is here. So it's going to give us 10, which is equal to 0. So I can write this one as 5z is equal to 7y plus 10. And z will be equal to 7y plus 10 divided by 5. Good. So this is how we solve. This is how we are going to solve this question here. So we are going to let y to be an arbitrary number, right? So I'm going to say that let y is equal to t. So I'm going to let y to be equal to t, so that my z will be equal to 7t plus 10 divided by 5. So now I know y, I know z. I can find for x. So let's go and find for x. From here we are going to plug them in. So x is equal to z minus 2y minus 3. So now x is equal to 7t plus 10 divided by 5 minus 2. Y is t minus 3. So let's try and simplify this and see what we are going to get here. So x will be equal to, LCM is 5, 7t plus 10. Then this 5 will multiply this, giving us minus 10t. 5 times 3 is going to give us 15. So this is going to give us minus 3t and then minus 5 divided by 5. So this is what we are going to get for x. This is what we are going to get for x. So now let's write it and see what we are going to get. Let's write it and see what we are going to get. So we are going to have something like this. Our x, y, and z. So now x is equal to minus 3t minus 5 divided by z divided by 5. And y is equal to t. What is z? Z is 7t plus 10 divided by 5. Divided by 5. So this is what you are going to get. Now we want to form the function. And we can see that this is in the vector form, right? So we can form this one in the parametric form. So we can write this one as, I can write this one as x is equal to minus 3t minus 5 divided by 5, and then I can make t the subject here. So when I want to do that, I'm going to have something like this. Let me see. Yeah, I'm going to have something like this. 5x is equal to minus 3t minus 5, and making this one the t the subject, I'm going to have minus 3t is equal to 5x plus 5, and t will be equal to 5x plus 5 divided by minus 3. So this is when I'm making t the subject from x component. Let's talk about y component. So y component, y is equal to t. So making t the subject is t is equal to y. So that's what we are going to get from there. And then making t the subject from z, z is equal to 7t plus 10 divided by 5. And here we are going to have 5z is equal to 7t plus 10. So 7t is equal to 5z minus 10, and t will be equal to we are going to have something like 5z minus 10 all divided by 7. So finally, what we are going to do is, this is t, and this is also t. So they are going to be the same thing. So this is how we are going to write it in symmetric form. So we are going to have 5x plus 5 divided by minus 3 is equal to y, which is also equal to, or I can write this one too, I can write it like this. T is equal to y minus 0 divided by 1, so that it can form the function very well. So I can write this one as y minus 0 divided by 1, which is the same as 5z minus 10 divided by 7. So this becomes the symmetric form, right? And then if I want to write it in parametric form, what I'm going to do is I just have my x, y, z here. So I just add I, j, k to it. Then I'm done. So parametric form, I'm going to write it in this form. Let me open another sheet to show you. So the parametric form is, let me say, r of t is equal to si plus yj plus zk, right? And then just take it from there. So I'm going to write this one as x was equal to minus 3t minus 5 divided by 5, so I, and then y is t, so this, plus z is 7t plus 10 divided by 5, I think, k. So this is the parametric form, this is the symmetric form, and this is the vector form. Good. So that's what was the question all about. Now let's look at question B. Now find the equation of the plane containing the lines. Now I'll show you the trick. Now anytime you are solving, you are forming the equation of the line or the plane. Remember, we do something like this. R of t is equal to a plus, let's say AB, vector AB, t, right? And this vector AB here is the directional vector, and always the directional vector is below here. This is the directional vector. So you see that what we did here, when we form it in the symmetric form, this, and this are the directional vectors. So anytime you see a question like this, now this one, you can write this one as this. So you need to form this R of t by writing this one as, now this A here are the component here, and this here is the component here. So I'm going to write R of 1 of t to be equal to, now this A is going to be minus 1, it's going to be 1, minus 1 and 2. So here should be, always we should have minus there. So this one is plus because it was minus minus. That's why we are having plus there. And this one is come 2. Then plus, so this will be my directional vector, that is AB, vector AB. So this one is going to be 4, 2, 3, t. So this is my directional vector. Let me call it AB, or let me call it N1. So this one is going to give us something like this: 4i plus 2j plus 3k. Then same thing for the second one. Let me call it R2 of t. This is going to give us 1 minus 1 and 2 again, and then plus 5, 2, 3, and t. So if you look at the question that I was trying to solve here, you see that I maintain the minus at the denominator. I don't multiply the minus through. For example, here, I could have moved the minus 3 to this side and move this one to this side. But if you do that, you change the directional vectors. So here, they maintain it so that you can write out the directional vectors out. So this one, I'm going to write N2 to be equal to 5, 2, 3. Yes, so this is what is going to be my vectors. So my vector, I have 4, 4, 2, 3, and then I have 5, 2, 3. So now the question is asking us to find the equation of the plane. Now remember, with the equation of the plane, we need to use the normal vectors. And this becomes the normal vectors, which is the directional vectors, right? So we are going to use the directional vectors to find the normal vectors. So let me just, instead of making it and let me make it something like A1 and A2. So we've gotten the directional vectors. We need to form the normal vector so that we can form the plane. Now, one thing that you need to know is always your directional vector is the one below here. So you just pick them and then you are done. Good. So now for us to find the normal vector is equal to A1 cross A2. We need to cross the directional vectors. So let's go through that. This is going to be I, J, K. A1 is 4, 2, 3, and then A2 is 5, 2, 3. So that's what you are going to. Is it supposed to be 2 or 4? Okay, so I think there is a typing mistake here. This one's supposed to be 4. Sorry, this one's supposed to be 4. Yeah. This one's supposed to be 4. All right, so it means that this one is going to be 4, and then this one too is going to be 4. So let's put the 4 here. Good. So now let's try and find the function. So let's continue. So now I will be this out. We are going to have 2, 3, 4, 3 minus j, and then this one is going to be 4, 3, 5, 3 plus k. This one is going to be 4, 2, 5, 4. So now let's try and then simplify this. So I will be 6 minus 12 minus j, 12 minus 15 plus k, 16 minus 10. So don't forget, we have 7 questions that we are going through together. So let's see what we are going to get from here. Now this is going to give us minus 6i plus 3j plus 6k. So this is what you are going to get. So this becomes our normal vector. Now what is the equation of the plane? We know that equation of the plane is a, x minus x naught plus b, y minus y naught plus c, z minus z naught is equal to 0. So this is the equation of the plane. Now this a, b, c here, they are the normal vector. They are the coefficient of the direction in the normal vector. So my a here is this, and this is my b, and this is my c from the normal vector. So this is going to give us something like this: minus 6 x minus x naught plus 3 y minus y naught plus 6 z minus z naught is equal to 0. Now for x naught, y naught, z naught, we are going to use which one should we use? We are going to use the functions here. Which one should we use here? Let me see. Okay, good. We are going to use this one here. So a, because these are the ones which are common here. So we are going to use this and that. So we have 1, minus 2, and 1. This is the one that's going to give us the initials, like the position vector. So this is the position vector. So we are going to have this one to be, we are going to use 1, minus 1, and 2. So this is what we are going to use for our x naught, y naught. So this is x naught, this is y naught, and this is z naught. So don't forget, we need to use the position vectors. So these are the position vectors, which are the same. And then the down here is the directional vector that we use to form the normal vector. So now our equation is going to be minus 6 x minus 1 plus 3 y plus 1 plus 6 z minus 2 is equal to 0. So you see that whatever it is here, whatever here is basically what's on the top here. So That is basically what we have here. So what we are doing is we are just multiplying this one by the coefficient of the normal vector, coefficient of the normal vector, coefficient of the normal vector. So you need to pay attention to that. So now if I want to expand this, I'm going to have minus 6x plus 6 plus 3y plus 3 plus 6z minus 12 is equal to 0. And this is going to give us minus 6x plus 3y plus 6z. Then add this to this is 9. And from this is going to give us, I think, 3, right? Yes. So minus 3 is equal to 0. Then if I multiply 2 by minus so that this one becomes positive, I have something like this. Plus 3 is equal to 0. So this is the equation of the plane. This becomes the equation of the plane. So let me just hit on this one again. Now this becomes the directional vectors that we are going to cross them to find the normal vector. Now the normal vector, when you find the normal vector here are the coefficient of the equation of the plane, right? And the x0, y0, and z0 are the position vectors of this function here. So pay attention to that one. Now let's look at the next question, question 4. Question 3. Question 3, we want to talk about the velocity and then acceleration. Then we talk about unit tangent, curvature, and then principal normal, right? So let's start with I. Now for us to start with even I, we need to first find the position vector or the parametric equation. So what will be the parametric equation? Let me assume that that one is r of, and the function is in terms of t, okay? R of t is equal to si plus yj plus zk. So what are we going to get from here? We know that x is equal to a cos nt I plus or minus a sin nt j plus k, because z is equal to 1. So this is our r. So now we can now find the velocity. So then what is the velocity is equal to the r over the t when I differentiate the function for the first time. So let's just differentiate the function. So we are differentiating with respect to t. So when I differentiate cos, I get sine. But let me do something here so that you can see it very well. Let me write this one as a cos. Let me put this one in parentheses so that you can see minus a sine ntj plus k, so that you can understand the differentiation very well. Okay, so now let's differentiate this with respect to t. So when I differentiate cos, I get minus sine. So this is going to give us minus a sine nt. But when I finish, I need to differentiate what is inside the parentheses with respect to t. So when I differentiate nt, I'm going to get n because I'm differentiating with respect to t. And then I add my I. When I differentiate sine, I'm going to get cos. So this is going to be minus a cos nt. The same thing, differentiate what is inside the parentheses. We are going to get something like n again with j. And then when I differentiate this one goes to 0 because it's constant there. Let me try and simplify this, and I'm going to have minus an sine nt I minus an cos nt j. So this is the velocity. Now let's look at the acceleration, right? How are we going to get the acceleration? For acceleration, we just need to differentiate the velocity, or we differentiate, r 2 times, and then we get it. So let's just go through the process and see. So acceleration is equal to dv over dt, because we have already differentiated the function 1. So let's do that. Now I'm differentiating this function here with respect to t. So let's go again. This is minus an. When I differentiate sine, I'm going to get cos. So this is going to give us something like cos nt times, when I differentiate what is inside, I get n I. And when I differentiate cos, I'm going to get minus sine. So it makes it positive, an sine of this times and j. So when I simplify this, I'm going to have minus a n squared cos of nt I plus a n squared sine of nt j. So this is the acceleration when we differentiate it. Now let's look at II. With II, we want to now find the unit tangent. So these are, formula work and how to do the differentiation if you know how to do them. These are some of the questions that you need to do. Now, II, first one, which is alpha, we need the unit tangent, which is t, right? Good. We need the unit tangent. So the first question is, what is the formula for the unit tangent? We know that unit tangent is r prime divided by the magnitude of r prime, which is also the same as, we know that when we differentiate the position vector for the first time, you get velocity. So this is divided by this. So we know the velocity already, which is equal to what is here. This is the velocity. So let me put the v here. So since we know the velocity, let me just pick it and just go and place it down here. So we have the velocity already here. So all we just need to do is we need to find the magnitude. So let's try and find the magnitude of this. So magnitude of this means that we need to take the square root of the first function here, minus an sine an all squared plus minus an cos an all squared. So simplify this, we are going to have something like this: a squared n squared sine squared plus a squared n squared cos squared nt. So anytime you are dealing with unit tangent and it's involved with cos and sine, it's always the idea that, or it's always for you to remember that sine squared plus cos squared is going to be 1, and it will happen in this question. So let's see how we can do this. We can factor n squared, a squared n squared out, and it will be left with sine squared nt plus cos squared nt. And this is going to give us 1, right? Trig property. So this one will be left with a squared n squared times 1, which is the same as a squared n squared, and this one is the same as an squared, and this squared will cancel this, so I'm going to have an at the end of the day. So an is what I'm going to have. So now my unit tangent will be equal to the whole of this, which is the velocity, right? So I'm going to have minus an sine nti, and then minus an cos ntj divided by the magnitude, which is an. So since I have an on the top, I can factor it out. So I can factor minus an out, and I'm going to have sine nti plus cos ntj divided by an, and then an cancel an. So I'm going to have something like this: minus in brackets sine nti plus cos ntj. Now here you need to pay attention to it, because if you make a mistake here, it's going to affect the next question, right? Because the next question also depends on unit tangent. So the beta, which is curvature, now we are going to talk about curvature, right? So curvature goes with unit tangent. So it means that when I make a mistake in my first function, I'm going to get this one wrong. So make sure you get this one right, because we know that curvature is equal to magnitude of the unit tangent prime divided by r prime magnitude or magnitude. But I know that r prime is the same as the velocity, so I can write this one as prime divided by v magnitude, or this. So I have this magnitude here, which is the velocity, right? Magnitude of the velocity, which is equal to an. Now I have t, which is the unit tangent. So all I need to do is I need to look for t prime from here. So you see how a small mistake in the first one is going to affect the whole work. So now let's try and find for, this is t. So let me just bring it down and let's try and then get t prime from it. So let's try and get t prime for this. So this is going to give us t prime is going to give us, I have my minus out. When I differentiate sine, as we did, this is going to give us n cos nti, because when I differentiate cos, I'm going to get sine, I'm going to get cos, and I differentiate what is inside, it's going to give me the n. Then here, when I differentiate cos, I'm going to get minus sine, differentiate what is inside, so I'm going to have minus n sine ntj. So this is what I'm going to get when I just do the differentiation. So now I need this one before I can find the magnitude, right? So let's do that. So first I need t prime divided by vn magnitude. So this is the same as, now this one I can factor n out. When I'm writing, I can do that. So I'm going to have minus n out, or let me just do it here first. So here I can factor minus n out, or when I factor minus n out, this one will be n, this one will be minus cos nti plus sine ntj, right? So what I did, I multiplied 2 by minus and then I factored the n out. So this is going to give us n minus cos nti plus sine ntj divided by the magnitude of vn. What did we get? We had an. So we are going to divide this one by an, and then n will cancel n. So we have minus cos this I plus sine ntj divided by a. So this is what we are going to get when we find this. Now we are not done. What we just need to do is now we need to find the magnitude of the whole resource. So now let's find the magnitude of the whole resource. So magnitude of t prime divided by magnitude of this. So this here is constant, right? So all we just need to do is we can just factor the 1 over a out and then now find the magnitude of the one on the top, because we don't have anything in it like t or something like that. So this one is just a constant. Now we find this one. So this is going to be minus cos n all squared plus sine nt all squared. And this is what you are going to get. We are going to have 1 over a. This is the same as cos squared nt plus sine squared nt. And we know that this is going to give us 1. So we are going to have 1 here. And square root of 1 is 1. So I'm going to have 1 over a. So 1 over a is the curvature. So this is 1 over a for the curvature. Now let's look at the last question for question 3. Now we want to find the principal normal, right? So what's the formula for finding principal normal? So that is this. So principal normal n. Now the principal normal, what is the formula for the principal normal? Principal normal is equal to the unit tangent prime divided by the magnitude of unit tangent prime. So remember, we have the unit tangent prime already, which is here. We have it already. So all we just need to do is we just need to find the magnitude of the unit tangent, and we just plug them in. So you see that a small mistake in the first one, we are going to get everything wrong, because this is very simple when you are solving it. But a small mistake is going to, spoil everything. So let's go. This is a constant, so I can still have it here, and then now find magnitude of this. So minus, I think we've done something like this before. This squared, all squared, plus sine of nt all squared. So this is basically going to give us 1. So n square root of cos squared nt plus sine squared nt, and this is going to give us square root of 1, which is equal to n times 1, and this is n. So this is giving us n. So it means that our normal will be equal to the n minus cos of nt I plus sine of nt j, all divided by what we just had, n. And this will cancel this. So the principal normal is minus cos of nt plus sine of ntj, and this one is I. So this is the principal normal, right? Principal normal. Let's look at question 4. Let's look at question 4. We have 7 questions, so we are almost there. Now question 4, we want to show that this point lie on a plane. In other words, we can say that this is coplanar, right? So what we are going to do is, for this line to lie on the plane, then we are going to pick our first point, which is P, and pair the P with all the other point. So we are going to look for PQ, we are going to look for PR, and we are going to look for PX, right? And for us to show that this lies on the plane, what we are going to do is we are going to look for vector PQ dot PR cross PS should be equal to 0, right? And then we can also look at something like PQ dot cross PR dot PX should be also equal to 0. If you're able to do this, then we are going to say that the point lie on the same plane. So that's basically what we just want to do. So let's try and then figure out this vector. So this is the same as Q minus P, this is the same as R minus P, and this is the same as S minus P, right? So let's try and figure it out. So we are going to have something like this. So now this is going to give us something like this. This is the same as Q is this. So let me just pick it up. Q is this. So this is minus 1, 2, 3 minus P is 2, 0, 1. This is equal to, I can bring it here. So minus 1 minus 2. This is going to give us minus 3. Then 2 minus 0 is going to give us 2. And then 3 minus 1 is going to give us also 2. So we are done with that one. Here, R is this. So I'm going to have 3, 2, 2 minus 2, 0, 1 again. So 3 minus 2 is 1. 2 minus 0 is 2. And 2 minus 1 is 1. Then the last one we are going to have, this is S. So 3 minus 6 minus 3 minus 2, 0, 1. So let's do that. 3 minus 2 is 1. Minus 6 minus 0 is minus 6. Minus 3 minus 1 is minus 4. So these are the points that we are going to get when we do them. So now let's try and figure them out. Let's try and see if we are going to get them to be 0. So first we want to show that PQ dot PR cross PS is equal to 0. But this is scalar triple product. This is scalar triple product. So we can write it like this. So what is PQ? PQ is 3 minus 3, 2, 2. So minus 3, 2, 2. What is PR? This is PR. That one is 1, 2, 1. 1, 2, 1. And then the last one is 1 minus 6 minus 4, which is here. So we are going to have 1 minus 6 minus 4 here. So now let's try and then figure it out. So this is going to give us, let me just bring this one here. Minus 3 will be left with 2, 1 minus 6 minus 4. Minus 2 will be left with 1, 1, 1 minus 4. And 2 plus 2 will be left with 1, 2, 1 minus 6. So cancel this one out, it will be left with this here. Cancel this one out, it will be left with this and this here. And cancel this one out, it will be left with this here. So let's figure out if it is 0. Minus 3 times, now 4, this one is going to be minus 8 plus 6 minus 2 minus 4 minus 1, and then plus 2 minus 6 minus 2. So this times this minus this times that in the same pattern. So this is going to give us minus 3 times minus 2, minus 2 times minus 5, and then 2 times minus 8. This is going to give us 6. This is going to give us plus 10, and this is going to give us minus 16, and this is equal to 0. So this is equal to 0. Now let's check the last one, and then we see what we are going to do. Now the last one, this one too can be written as px dot pq cross pr, right? So I can write this one first because it's dot product. Dot product is kind of commutative. It is cross product that which is not commutative. I cannot write this one first before this when I'm dealing with cross, right? But this one is dot here, so I can write it this way. So I want to show that this one too is equal to 0. So let's do that, and then let's see. So px dot pr cross pq. Good. So that's what we are looking for. So now let's build it. So this is 1 minus 6 minus 4. This is minus 3 2 2, and this is 1 2 1 from what we had for this component from here. Now let's try and see if we are going to get 0 for this. So this is going to be 1. So the same thing. Pick 1 1. Then we're going to have 2 2 2 1 minus 6 minus 3 2 1 1 minus 4 minus 3 2 1 2. So same thing. Maintain this, cancel this. You have what is here. Cancel this and this. You have this here, and then cancel this. You have this one here. Now here is minus because I'm using the cofactor plus minus plus for the top here. So this is going to give us 1 times 2 minus 4 plus 6 minus 3 minus 2 minus 4, and this is minus 6 minus 2. So this is going to give us minus 2 plus 6 times minus 5 minus 4. This is going to give us minus 8. So what are we going to get here? Minus 2. This is going to give us minus 30. And then 4 times 8 is 32. So it's going to be positive 32. And this is going to give us 0. So indeed, we are going to say that point P, Q, R, S are coplanar, or they lie on the same plane. So that's what the question was telling us to do. Show that the 4-point line. So it's indeed, they lie on the same plane. Let's look at question 5. Let's look at question 5. Now question 5, they've given us A, B, C, and we want to look for this here. So first, we need A minus B, 2A minus B plus C before we can do the dot. So let's do that. 2 times A. So 2 times minus I plus J minus 2 square root of 2 square root of 2K, and then plus C, which is minus I plus 2J minus 2K. So that's what we are going to get. Now, what you just need to do, you need to be practicing, right? So when we are done, you can just pause video, practice, and then it prepares you for the exams. So 2I minus plus 2J minus square root of 2I plus square root of 2K minus I plus 2J minus 2K. So group items, the ones with I, the ones with J, and the ones with K. So let's see what we are going to get from here. All right, so let's see. Now I can see that I have something like this and this with I and another I here. So this and this is going to give us 3. So we are going to have minus 3 minus 2 square root of 2i. So I'm just combining this, and this will give us 3i, but the I is out. And then I have this one here, which is 2 square root of 2. Then go with j. I'm going to have plus 4j. And go with k, I'm going to have plus square root of 2k. So now that I have this one, now I can figure out my dot product. So let's do that. We need 2a minus b plus c dot a. Now we have this right here. So now we can just do the dot. So this will be equal to minus 3 minus square root of 2i plus 4j plus square root of 2k dot a is minus I plus j. So direction by direction. So this times this is going to give us minus 3 minus square root of 2. This times this is going to give us plus 4. And there is no k, so that aspect will go to 0. So now we are going to have it's going to be 3 plus square root of 2 plus 4, and this is 7 plus square root of 2. So this is what we are going to get for the first one. What is the second one? I find the angle between A and B. We want to find the angle between A and B. So angle between A and B, we need to remember the dot product formula. A dot B should be equal to magnitude of A, magnitude of B, cos theta. So if I want to find cos theta, A dot B divided by magnitude of A, magnitude of B, and theta will be equal to cos inverse of A dot B divided by this and that. So this is what I'm going to get. So now let's try and figure out A dot B. So we know A to be minus I plus j, and we know B to be equal to square root of 2i minus square root of k. Is that right? Yes. So now let's figure out A dot B. So minus I plus j dot square root of 2i minus square root of 2k. So this time this is going to give us minus square root of 2. There is no j here, so it goes to 0. There's no k2 here, so that one too goes to 0. So the dot is just going to give us that. Now let's find magnitude of A. This is square root of minus 1 squared plus 1 squared. This is square root of 1 plus 1, and this is going to give us square root of 2. Now here, let's also find the magnitude of this. Now magnitude of this is going to be square root of 2 squared plus minus square root of 2 squared. And guess what we are going to get from here? We are going to have 2 plus 2, and this is square root of 4, and this is 2. So now we know this, we know this. So what I can do here is I can now find magnitude of A dot magnitude of B, and this is going to give us 2 root 2. Now let me just make this one. All right, so this is magnitude of B. So now let's find theta. So theta is equal to cos inverse of, now the dot product, what did we get? We had minus this divided by the magnitude. We had 2 square root of 2. This is the same as cos inverse of minus 1 over 2, because this will cancel this. And then what is cos inverse of minus 1 over 2? This is going to give us 6, 0. So this is what we are going to get. Good. Now let's look at I. We want to determine the unit vector in direction of A cross C. In direction of A cross C. I love this question because it's kind of very simple but long. You know, you need to pay attention to it before you can do that. So the unit tangent, we can get the unit tangent. Sorry, did it say unit tangent? Oh, unit vector from the normal vector, right? So remember, unit tangent is equal to the normal vector divided by the magnitude of the normal vector. right? So how do we get a normal vector? Anytime we want to get a normal vector, we need to cross it, right? So we are going to cross A and C because that's what we need. So since we have, okay, even they wrote it here, A cross C here. So we are going to cross this and that. So let me just write them here and send them. So A is equal to minus I plus J, and then C is equal to minus I plus 2J minus 2K. Let me just write this one and send it down there. Good. Let's go down. Okay, so we have A and B, A and C there. So let's go I, J, K. This is minus 1, 1, 0. This is minus 1, 2, minus 2 from this. So now let's figure it out. This is I, 1, 0, 2, minus 2, minus J. This is minus 1, 0, minus 1, minus 2. And K is going to be minus 1, 1, minus 1, 2. Good. I is minus 2, minus 0, minus J. This is going to be 2 minus 0 plus K, and this is going to be minus 2 plus 1. This is going to give us minus 2I and minus 2J and minus K. Good. So that's what we are going to get. So as I said, this is the normal vector. So this is this. So now our unit tangent will be equal to, okay, we need to find the magnitude first. So let's find the magnitude. Magnitude of this is minus 2 squared plus minus 2 squared plus minus 1 squared. So 4 plus 4 plus 1, and this is square root of 9, and this is going to give us 3. Indeed. So this is going to give us our unit tangent to be minus 2I minus 2J minus K divided by 3, because we need to use this formula right here. Good. Let's do the last one under this. We want to find the volume of a paralleloparallel that has A, B, and C as sizes. So the volume of a paralleloparallel is just A dot B cross C. So let's just write them here, and then we just have it there. So let's just write it down. The volume is going to be this. So the volume, so that's the last question here. The volume is equal to A dot B cross C. So that's basically what we just need to do. Now we know that A is minus I plus J. So A is this plus J. We know that B is square root of 2I minus square root of 2K. And we know that C is, I wrote C here, minus I plus 2J minus 2K. Good. So we just put them here. So first one is A. So we are going to have minus 1, 1, 0, square root of 2, 0 minus square root of 2, and then minus 1, 2 minus 2. So that is what we are going to get from here. So we just do the normal thing, and then we are done. So minus 1, 0 minus square root of 2, 2 minus 2, minus 1, and then square root of 2 minus square root of 2, and then minus 1 minus 2. You know, this is basically 0, so it's going to be plus 0 because I multiplied it by 0. So no need to write that. This is minus 1, 0 plus 2 root 2, minus 1. This is minus this. Then this will be minus square root of 2, and then plus 0. So this is going to give us minus square root of 2, and then minus 1. This is going to give us minus 3 square root of 2, and minus 2 square root of 2 plus 3 square root of 2. And this is going to give us square root of 2, and we are going to call it cubic unit. Yeah, so that is what you are going to get for this. So now let's look at the next question, which is question 6. Now write down the equation of the line which passes through the points, this and that. So what I'm going to do is I'm going to let this one to be A and this one to be B. So A is equal to minus 2, 1, 3, and b is equal to 4, 2 minus 2. So r of t is equal to a plus ab t, because they've not given us the directional vector, right? So what we just need to do is we need to find vector ab to get our directional vector. So here we are going to have vector ab to be b minus a, which is the same as 4, 2 minus 2 minus 2, 1 and 3. So this is going to give us 4 minus minus, so this is going to be 6, and then 2 minus 1 is going to give us 1, and then minus 2 minus 3 is going to give us minus 5. So this is what you are going to get for our directional vector. So r of t is equal to minus 2, 1, 3 plus 6, 1 minus 5. Now I can write this one as minus 2, 1, 3 plus, okay, there should be t here, 6t, t minus 5t, when I multiply through by t. Then I can write this one as minus 2 plus 6t, 1 plus t, and then 3 minus 5t. So this becomes the vector equation. Now I want to write it in parametric form. Then when I finish, I'll write it in symmetric form, right? So the parametric form is going to be r of t is equal to minus 2 plus 6t I plus 1 plus t j plus 3 minus 5t k. So this is the parametric form. Now let's write it in symmetric form. Now in symmetric form, what I'm going to do is I'm going to write this one as this. Now remember, this is x. Remember, this is something like this, xi plus yj plus zk. So my x is equal to minus 2 plus 6t. So now I can make t the subject. So I'm going to have 6t to be x plus 2, and then t will be equal to x plus 2 divided by 6. Now y is equal to 1 plus t, and t will be equal to y minus 1, and t is equal to y minus 1 divided by 1, because we need to have, so remember, everything that we are having here is a directional vector. When I finish, I will show you. Then now we are going to have z is equal to 3 minus 5t, and then minus 5t is equal to 5 minus 3, and t is equal to z minus 3 divided by minus 5. So symmetric form, since this one is t, and t, I can write this one as this plus 2 divided by 6, which is equal to y minus 1 divided by 1, which is equal to z minus 3 divided by 5. So you see, this is the directional vector, as I said in the one of the questions, 6, 1, 5. Let's go and look at the directional vector. You see that the directional vector here is 5, 6, 6, 5 minus 1. I think I omitted the minus. So the minus is here. So you see that 6, 1 minus 5. That is the directional vector here, right? And then the one up here is the position vector, meaning that that's the first vector. This one is minus 2, this is 1, and this is 3, right? So we are going to have something like this. What is it? Minus 2, 1, and 3. So that's basically what we are going to get from there. Now let's look at, this one's supposed to be question 6a, and this one's supposed to be b. So this is a. Now let's look at b. Now b, we want to show that these lines are perpendicular. This is very simple. We just need the directional vector to dot them, right? And don't forget, the directional vector is always here. So you pick the directional vectors and you just dot them and see if you are going to get 0. And if it is 0, you are there, you are done. So that's basically what we just need to do. But what I can do for you is I can try to form the equations and see what we are going to get. So now we have the functions as x plus 2 divided by 2, which is equal to y minus 5 divided by 3, which is z minus 7 divided by minus 1. Other equation is x plus 4 divided by 5, which is equal to y minus 1 divided by 3 minus 3, which is equal to z minus 3 divided by 1. So remember the directional vectors here is going to be, if I'm picking the first one to be A, is going to be 2, 3, and minus 1. This will be the directional vector. And then the other directional vector for this, I'm going to have 5, minus 3, and 1. So all I just need to do here is dot A and B and see if it's going to be 0. Yeah, so show that the lines are perpendicular, that's all. But for more, since this one is subjective and we need to get more point, then here it's better for us to form the equation before we do that, right? So what I'm going to do is, for the first one, where is it? For the first one here, I'm going to let t to be equal to the function so that we can form R1 and then R2. So this one, if I let t to be equal to this, I'm going to have t is equal to x plus 2 divided by 2. And this implies that 2t is equal to x plus 2. And then x will be equal to 2t, or x will be equal to minus 2 plus 2t, right? That is for x. Let me open another page so that we can make use of them. Good. So that is that. Then when I pick this one, remember it's symmetric as we saw from here. For us to combine them, you will see that we take the t from the y, from the x, and then from the z. So this one too is going to give us something like this. Second one is t is equal to y minus 5 over 3. And we are going to have 3t is equal to y minus 5. And y will be equal to 5 plus 3t, right? The last one is going to be t is equal to z minus 7 divided by minus 1. So minus t is equal to 5 is equal to z minus 7. And z will be equal to 7 minus t. So if we want to form the parametric equation, then R1 of t will be equal to, this is my x, so I'm going to have minus 2 plus 2t I plus, this is my y, so I'm going to have 5 plus 3t j plus 7 minus t k. But what we are going to pick is, you see that when we are done, still we are going to pick the directional vectors, which is this, this, and that. And that's all that we need to use. And then we are done. So now let me try and do this one sharp, very fast. So this one, when I do it, I'm going to have the first one, when I equate it to t, x plus 4 divided by 5, 5t is equal to x plus 4, and x will be equal to minus 4 plus 5t, right? Good. And then this one too is going to be, the next one, which is y, is going to be t is equal to y minus 1 over minus 3, and then minus 3t is equal to y minus 1, and then now y will be equal to 1 minus 3t. Last one is z, t is equal to z minus 3 over 1, and then t is equal to z minus 3, and z is equal to 3 minus 3 plus t. So our R2 is going to be x. What do we get for x? X is minus 4 plus 5t I. Y is 1 minus 3t j plus z is 3 plus t k. And directional vectors are the one with t, right? As we learned from here. These are the directional vectors, the one with t. So when I come to this equation here, the one with t is going to be this, this, and that. When I'm just reforming the equation again, right? For example, let me try and reform this one again. This one can be written as minus 4, comma 1, comma 3. So I'm just picking the one without t, sorry. Then plus the one with t is 5 minus 3 and 1. So 5 minus 3 and 1, which is going with t, and is going with ijk. So that's basically what we just need. So let's just throw them away and then just, solve the function. So now from here, we are going to have a to be, the first one is 2. The first one is 2, 3 minus 1, and b is 5 minus 3 and 1. So that's basically what you are going to do. So when you form it this way, then now you pick this one as your b. So it means that even the one that I did here, I need to also write it again. So this one can be written as minus 2, 5, 7 plus 2, 3 minus 1 and t. So pick the one without t in 1 plus the one with t here with t. So this one 2, 3 minus 1. So 2, 3 minus 1. So let's dot it and see what you are going to get. So a dot b is going to be 2, 3 minus 1 dot 5 minus 3 and 1. So let's do it. 2 times 5 is going to be 10 plus 3 times minus 3 is going to be 9, minus 9, and minus 1 times this is going to be this. So this is going to give us 10 minus 10, and this is equal to 0. So we've showed that this is what? Perpendicular. Now, as I said, since this one is section B, instead of you picking the point straight, what you can do is you try and form this, form your t, get your x, get your y, get your z, form this R1 and form it in this form so that you can pick this one as your directional vector. Then do the same thing for the second one to also form something like that before you pick it and dot them. If not, this one is going to be just this one, right? Because this is section B and you are not going to get maybe the point that they want to give. Maybe they want you to get the vector, right, or the plane before you take it from them so that you can get it. But if it is subjective or multiple choice questions, then you can just use the shortcut to show that it is there, right? So let's do the last question and then we are done. Now I chose this last question because of this question. If you have not solved it before, maybe you can get confused and say what you are doing is not correct, and then you are going to say that no, it's wrong, because we are going to get indeterminate somewhere. So you see that when you get there, you'll be like, no, this is not correct. I've never solved a question that getting something like this. So let's jump right in. So I will leave basically I can't leave it because if I want to leave it, then it means that I'm going to, should I leave it for you guys to do it? Because, okay, so let me try and do some for you. So the position vector is going to be t over t plus 1 I plus 2t divided by t plus 1 j plus 3t divided by t plus 1 k. So now first, for us to find the velocity is equal to the r over the t. So we need to differentiate this. So here we need to use the quotient rule to do that. So I'll just go to straight. Quotient rule, I maintain the down, differentiate the top minus, maintain the top, differentiate the down, and t plus 1 squared. So this is the I direction. Plus j direction will be t plus 1 times 2 minus 2t times 1 divided by t plus 1 squared. And then k direction will be t plus 1 times 3 minus 3t times 1 divided by 1 t plus 1 all squared. When I simplify this, I'm going to have t will cancel t, so I'm going to have 1 over t all squared I plus, when I simplify this, 2t will cancel 2t, so I'm going to have 1 divided by t plus 1 squared. When I simplify it, this one will cancel this one, so okay, this one's supposed to be 2. This one will cancel this, so I'm going to have plus 3 divided by t plus 1 squared. So this is what I'm going to get for velocity. Now let's try and find for, what's the next question? We want to find acceleration, right? So we need to differentiate it again. So, okay, so let me just pause here and then just leave it to you for you to also try. See you. I think this is the last video for the course. So maybe I'll see you in level 300 when you are taking advanced. So always see you in the next video, right? Bye bye.